2, 1. Okay, so let's put this to practice, okay? So here we go. Write this down. Let's start. Let's see. Let's start with the first term. We'll end with the fourth term. My rule is going to be n squared. Okay, so write that down. Probably most of you are saying, what the heck is going on here? I don't even know what time this class ends. Do you know what time the class ends? So let's write down a table so we can get an idea of what this is telling me to add up. Okay? So here's my n. What's my rule? N squared. I want my first term, my second term, my third term, and my fourth term. What's my first term? Is n squared. So I square my n, I got 1. What's my second term? What's my second term going to be, Ethan? What's my second term?
4.
4. 2 squared is 4. What's my third term going to be? Billy, what's my third term going to be?
9.
9. And what's my fourth term going to be? Brett, what's my fourth term?
16.
Boom. What does this tell me to do to these terms? What does the sigma tell me to do, Jackson? What's the sigma telling me to do?
I don't know.
It starts with an A and ends with a D. D.
Add.
It says to add them up. Right? The sigma says take them and add them all up. The first term all the way to the fourth term. Make sure you square them. So the sigma says 1 plus 4 plus 9 plus 16, which is 10, 30. So guess what? This is equal to 30. And that's what summation notation means. Start with the first term, end with the fourth term, right? And by the way, this can go into infinity, and I'll show you that in just a second. Are there any questions? I'm going to take roll. Are there any questions while I'm taking roll?
Yeah, what's the point of putting it in like this, like, I don't know, it's called sigma form?
What's the point?
Yeah, because how is it different than just how we did it yesterday? Now we just have to...
Oh, because instead of writing all these numbers out, you just have this. And then you know what they're asking. Instead of having to say 1 plus 4 plus 9 plus 16, and this can go up to 50. Instead of writing all those out, you can just have a little signal thing, symbol here that tells you what it all is.
Oh, that makes sense.
And we'll see. This gives us more tools right here when we get over here that'll help us too. All right. Dun, 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 bum, bum. Julissa Abonce.
Here.
Sam Adams.
Here.
Cassandra Casillas. Nathaniel de Guzman.
Here.
Miley Fisher.
Here.
Carlos Gomez.
Here.
Billy Gonzalez.
Here.
Brett Hare.
Here.
Linda Lopez Hidalgo.
Here.
Maya Lopez. Angel Lopez.
Here.
Abraham Lucio.
Here.
Jackson Moreno.
Here.
Ethan Montes.
Here.
Emma Montoya.
Here.
Mara Ortega.
Here.
Montserrat Pedrosa.
Here.
Kevin Quintana.
Here.
Ian Ramirez.
Here.
Angel Rojas.
Here.
Bryson Santos.
Here.
Thomas Servin.
Here.
Samantha Velasco. Alonzo Vitella.
Here.
Dennis White.
Here.
And Elise Williams.
Here.
All right, here's who I have absent. Cassandra Casillas, Maya Lopez, and Samantha Velasco. Cassandra, are you here? No? Maya? No? Samantha? I'll have to sneeze. Woo! All right. Okay, now, Maya, you're not there. I thought I saw you there. If anyone sees Maya, let me know. Okay. So let's take a look at some of our notes in the book here, just because I think that they write it out really good here. So I want you to see this. Like you can have a finite series and an infinite series. I'm assuming you guys can see what I have here. Okay. You can have a finite series and an infinite series. So look, this tells me to add 2 plus 4 plus 6 plus 8. How to write that in sigma notation? Instead of writing 2 plus 4 plus 6 plus 8, you write, I start with my first term, I end with my fourth term, and I'm going to multiply by 2. So 1 times 2 is 2, 2 times 2 is 4, 3 times 4 is 6. So this is finite because it tells me to end at 4. This here is an infinite series. How do I know? My first term is 1, but sometimes we can say it goes up to infinity. Now, this is how you'd write it out. We cannot find the sum of this because it goes to infinity. It's going to take us forever to add that up. There's some that you can actually do. Okay? Again, this is called this little thing here is called sigma notation. That little funny looking E is sigma notation. Okay. So here's another thing. Now that you know that, okay, now to help further answer your question, Brett, about what's the point of this, or why would we do it that way? We could just write it out. Well, sometimes there's some shortcuts with our sigma notation. Okay? So I need you to write these down. Here's some little rules, some examples of things that can help us so I don't have to add everything up. Okay, so write these down for now, and I'll explain these in just a second. If I have sum of n terms, write this down. If I have my first term is 1, and my last term is n, whatever, if my rule is 1, okay, then that's going to all add up to whatever n is. Okay, so just write that down. I'll explain that in just a second. Write that down. Okay, here's another one. I'll explain this one in just a second too, but I want you to write it down. What if my rule is I? That means 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. I'll explain that in just a second. Instead of adding them all up, it's going to be n. My first term is 1. My last term is whatever n is. It's going to be n times n plus 1 divided by 2. Okay? Now I know you're saying, Sensei, this doesn't make any sense. Just write it down and I will explain it in more depth. Depth. Couldn't believe it's 4th period already, though. I guess this day, it kind of goes by fast, but kind of goes by slow. I guess it depends on if your teachers met with you today, right? Ian, did all your teachers meet with you today?
No. Like,
Am I the only one? Huh?
You in first period. That's it.
Oh.
Yeah.
Well, I guess you didn't have to Zoom all day today, just for 2 hours. I'm probably the longest one. This is going to take all period. I'm not lying. We all period first period, Ian?
No, he just talked about a couple things, and that's it.
Oh. How are you,
Yeah.
Kevin? Do you meet a lot of people today?
No, just second period and this period.
Just two? What do you have second period?
English.
Is that a rooster I hear over there, Kevin?
Yeah.
Do you guys have chickens at your house, or is that just your neighbor or something?
No, roosters and chickens.
Really? Are the fresh eggs better than the store-bought eggs?
They're all right. They're the same.
Well, that's cool. Do you have to clean out is it your job to take care of them and stuff, or who does that?
Sometimes, yeah.
All right. Well, it sounds like they're going crazy and having a party over there. Your roosters are just going crazy. That's crazy. All right. Now, if my first term is 1 and my last term is n, but I'm squaring my term, I'm squaring it, then instead of adding them all up, I can say n times n plus 1 times 2n plus 1, all divided by 6. So write that down. My wife wants to get chickens, but I'm all, man, it's kind of a lot. Is it a lot of work, Kevin, to watch all those chickens?
Well, we don't have that much. We only have like 5 roosters and 5 chickens. But yeah, it's kind of a lot of work.
What do you do with the roosters? I mean, do they just make more chickens with the chickens? Because they don't lay eggs or anything.
Yeah, they do.
The roosters?
Oh, not the roosters. The roosters are just there.
They're just there. Oh, because you have little babies and they end up being roosters or something? Like,
chicks.
You have little chicks and they're all, I don't know if there's going to be a rooster and then it's a rooster. Do the roosters ever fight each other or anything?
No, because they're in their own sections.
Oh, would they fight each other if they're all together trying to get up to the chickens?
Most likely.
Okay. Actually, people do rooster fights. That's illegal. Okay. Let's explain this. Here we go. Can I explain it, or does anyone need more time? Anyone need more time? All right. Let's do it. Okay, so what does this mean? So look it. Let's say instead of I, we're doing n. Instead of n, we're doing I. Say my first term is 1. We go up to n. Okay? And I have 1. Now, let's change this to, let's say it's 7 instead of n. What this means, this is what this means. N, 1, first term, second term, third term, fourth term, fifth term, sixth term, seventh term. Okay. What does this tell me my first term is going to be? It says it's going to be 1. Okay, fine. What's my second term going to be? My second term is going to be 1. What's my third term going to be? 1. What's my fourth term going to be? 1, 1, 1, 1. All this is saying is each term is going to be 1. My first term is 1, second term is 1, third term. So if I add them all up, going up to 7, what's it going to be? 1 plus 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 1. 1, 2, 3, 4, 5, 6, 7. What's 1 plus 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 1? Abraham, what is it?
7.
7, i.e., my answer is that right there. That's what it's saying. If I have a 1 there, my answer is going to be whatever number's on top. Boom. That is my answer. That's all it means. Okay? Makes sense? Raise your hand if it makes sense. Put your hand in front of the camera if it makes sense. Okay. Questions? Other questions? Because I can move on to the next one. Questions? I'm going to erase this in 10 seconds. 5.
Wait, what does the I mean again? Like on the bottom?
This is the first term. It means I start at 1.
Oh, okay, thank you.
You're welcome. Last term is 7. End at 7. This only works if my first term is 1. It only works if my first term is 1. I'm going to erase this in 5 seconds. 2, 1. Bling, 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 bling. Bling, 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 bling. Bling, bling, bling. Bling, 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 bling. Abraham, does that hurt your ears when I do that?
No,
Okay, good. Is it nice? Is it nice? Is it soothing to the ears, Abraham?
not really.
Oh, it's not soothing. I can say soothing stuff. Actually, I might get fired if I say soothing stuff, so I won't say soothing stuff. Okay, so here we go. Let's do this one. Now let's put a number for my last term. Let's say it's 5. Okay. Let's say I ended my last term, and I'm gonna do. Well, let's call it. We'll just say it's I. What is this saying? What is this saying? This means if I have my first term, let's call this n. We're used to n. N. Let's say it's n. I'm gonna write. You can do I n. I'm gonna do n. We're used to n. I'm changing it to n. I'm sorry. Just so you guys can understand. Boom, boom, boom. So I have my first term. What term do I end with? Carlos, what term am I ending with this one? What term am I ending with?
5.
5. So I go up to 2, 3, 4, 5. Boom. Okay. Now it's saying that my result is going to be n. My first term is n. And what am I do? It's going to be n. So if it's equal to n, that means 1 is going to be 1. You plug in 1 in here. You plug in 2, what do you get? 2. You plug in 3 here, what do you get? 3. You plug in 4, what do you get? 4. You plug in 5, you get 5. Do you guys understand the rule? All right, Julius, I guess I'll see you. So the sigma tells me I add them up. 1 plus 2 plus 3 plus 4 plus 5. Look at all this work that I'm doing here to solve this. 3, let's see. 10, 15. Add it up, I get 15. What this tells me, instead of doing all of that, I just go n times n plus 1 divided by 2, and I should get my answer. N, so instead of this, I should just go n times n plus 1 divided by 2. I should get my answer. Okay, well, what is my n? Thomas, what's my n here?
The number, right?
Yeah, tell me the number.
Oh, 1.
Nope. N. N. Look here, Thomas. N. What's my n here? N is, right?
5.
5. Oh, maybe that's why they do I, because they get confused. It's the number up here. Is the 5, right? So let's plug in our 5. 5 times 5 plus 1 over 2 is equal to 5 plus 1 is 6 times 5 is 30 divided by 2 is 15. So instead of adding all those up, I did n times n plus 1 divided by 2, and I get that. Why would we do this? Because if it ends up being like 30, right? I don't want to have to add them all up to 30. I'll just do 30 times 30 plus 1 divided by 2, and I'll get my answer. Okay? Instead of adding them all up. Now, the final one is I squared. Okay? So let's go like this. Let me change this back to I. Even though, because it's n, so you know that they're not confused. I just, I. So this will be I squared. And here's my n. Right here. Let's say it's 4. Okay? Now we're doing this rule. Because I'm doing the I squared. If you see that, I know, oh, I squared. I'm going to do this rule. I is the one I did before, which I wrote as n. Doesn't matter. I squared is going to be this rule here. So what is it going to be? Let's write the rule down. N. And then we have n squared. I'm going to square it. 1 squared is 1, 2, 3, 4. 2 squared is 4, 3 squared is 9, 4 squared is 16. This tells me to add 1 plus 4 plus 9 plus 16. Did someone come to class? Laura's late. So you add them up. 20 is equal to 30. Okay. So this is equal to 30. But what this tells me is I go, instead of adding all those up, I go n times n plus 1 times 2n plus 1 divided by 6. Which gets easier if this number gets bigger. You'd rather use this here. But I was trying to show you that it works. N times n, so it's, what's my n equal to here? Who is that over there? Can't see. Elise, what's my n for this? Which number is my n here?
I'm not too sure.
Yes, you're right. It's 4. Did you say 4, Elise?
Yeah.
Yeah, good. So we plug in 4. It's the number that's up here. So I want to plug it into this equation. N times n plus 1 times 2n plus 1, all divided by 6. So 4 times 4 plus 1 times 2 times 4 plus 1, all divided by 6. Okay, so I should get 30 instead of adding them all up. Let's see if it works. 4 plus 1 is 5. 4 times 5 times 2 times 4 is 8, plus 1 is 9. All of that divided by 6. So 20 times 9 divided by 6. 20 times 9 is 180. Divided by 6 is 30. Boom. So that's the shortcut. Laura. Laura Punto. Laura. She's having trouble logging on. All right, are there any questions on that? So we get started on the assignment. I'm looking at the, what time do we get out here? 12:54. So we still have like 20 minutes. Okay. So I'm looking at the assignment here. We're going to start on 29. Okay. Oh. Hey, you guys, Mrs. Lawson's going to be here in 15 minutes. Mika, did you hear that, what I said about Mrs. Lawson? Okay, so we did 29. Okay, so let's write this. So number 31. Write these series using summation notation. Okay, now, so let's put this to work. Now you're going to say, what the heck? Let's see. I gave you a ton of information, so your brain's probably swimming right now. My brain is swimming. So here we go. Let's break it down. Let's do it. This is actually an easy problem. 7 plus 10. It's an easier one. They get harder than this. But let's start with the easiest. It's the easiest one. It's still hard, but it's the easiest one. Plus 16 plus 19. Okay, so write this using summation notation. Okay, write this using summation notation. Okay, before we do that, let's figure out what's going on here. So, right, adding means I write in summation notation, but let's figure out our terms. I have n. How many terms do I got here? That's the first thing we got to think. Angel Lopez, how many terms did I got here?
5.
I got 5 terms, right? Whoops, I wrote it wrong. 7, 10, 13, 16. Angel's right. So I have 5 terms here. Dude, to erase all these. My fingers are all dirty from doing this. But my first term is 7, my second term is 10, my third term, fourth term, fifth term. Okay, now we have to figure out the rule. Before we do summation notation, remember yesterday we figured out what is the rule. Okay, so remember, look what I'm doing here. I add 3, I add 3, I add 3, I add 3. And we said we also had to figure out the 0 term to figure out the rule for this. It's linear, right? It's linear because it's all adding by 3. It's linear. Brett, what's my 0 term going to be?
$19.
This is my 0 term. 0 term.
4.
4. How'd you get that?
-3.
So if you go add 3, yes, you subtract 3 this way. Remember we did this yesterday? Camila, remember we did this yesterday? Camila? Camila, I can see you. Can you hear me, Camila? Camila, can you hear me? Camila? Hello? Camila, can you hear me? Camila? Camila! All right. I don't know what she's doing. She can't hear me or anything. She can't even see the thing. All right, Bryson.
Yeah.
All right, Bryson. Do you know what the rule is here? What's my rule?
Is it +3?
3 times n, we're going to multiply that, plus
+4.
Yeah. You guys remember that? You guys remember that from yesterday? Do you remember that from yesterday now, Bryson, or no? Were you here yesterday? Were you here yesterday?
Yeah.
Okay. All right. Carlos, you remember that from yesterday, how to get that?
Yeah.
Okay, cool. I'm going to assume you all know how to do that. We did that yesterday. Watch yesterday's videotape. Or watch yesterday's if you don't know. So how do I write this in summation notation? Here's the answer that we were looking for. Summation notation. What do we start? This is not part of our rule. This was to help us get this. We start with the first term. We end with the, what do we end with? What do I put up here on the top? Dennis, what do I put here on the top?
5.
5. It's the fifth term. We end with the fifth term. And then what's my rule? I just have to put my rule, right? Montserrat, what's my rule?
3n plus 4.
There you go. And that is how you write this in summation notation. The hardest part was figuring out the rule. That was the hardest part.
Mr. Sanchez,
Yes, Jackson.
how did you get the rule 3n plus 4?
Well, I just spent like 5 minutes doing that. Were you watching or were you gone or something?
I was in the kitchen.
Oh, okay. See me after class then. Because I don't have to show the whole class all that over again. Okay, or watch it on the videotape. It's being recorded, so. All right. All right, let's do Let's do 37 because this is such a weird one. I'm gonna do 30. You guys do the rest, figure them out. And by the way, check out the solutions. Like I have the solutions here. They're in the modules to help you out because some of these rules are kind of weird. Okay, so let's look at 37. Okay, 37. Like this rule took me a while to figure it out. But once you figure out the rule, it's easy. The rules are kind of like, what the heck? Like 37 is like, man, what is your rule? So I'll just show you the rule. 37 is I'm going to take -3 plus 4 minus 5 plus 6 minus 7. Hey, Layla. Mika. Hey, make sure you and Layla are ready to go right now because Mrs. Lawson's going to be here any minute. Like, are your shoes on right now? Okay. All right. So, sorry, I have to parent. I'm parenting at the same time. That's what happens when I get home. Okay, so what's my rule going to be? So here's my rule. My rule for this is going to be, this is just weird. So it's -1 I or n, -1 n times n plus 2. Okay, that's my rule. Okay, so let's see if we can write this out. I have the rule right here. Here's my rule. Here's my rule right here. -1 to the raised to the n, because this is going to switch the signs. Either way, doesn't matter. Here's, let's write out our sigma notation. First term, second term, third term, fourth term, fifth term. I equals what? What do I put down there? Okay. Abraham, what do I put here for my I is equal to what?
I'm not sure. -1?
What term is
Or
this?
3? Or
No. What term is it? It is -3, but what term is it?
one?
It's the first term.
Oh,
What's this term?
the second.
What's this one?
The third?
What's this one?
Fourth?
Fifth.
Fifth.
So this is saying, hey, what's the first term? What's it going to be? What am I starting with?
-3.
But what term is it?
Oh, the first one.
I start with the first term. Okay? And then Ian, what do I put up here?
You put 5 because it's the 5th term.
Yep, got that, Abraham? And with the fifth term.
Mm-hmm.
Okay, now what do I put here? Bryson, what do I put here?
-1 to the n exponent times n plus 2.
Very good. And then that's how you do it. The hardest part is getting the rule. I'm just giving you the rule. Okay, the rule is like if I plug in 1, I'm going to get -3 because 1 to the, anyway, every time I plug, it's going to switch the sign. You guys can play around with that. We're just running out of time. I want to try to get this. We have about 10 minutes left. But anyway, okay. Let's see. What are we going to do next here? I'm going to get rid of this in 10 seconds. All right, moving on. Anyone need it? 5, 4, 3, 2, 1. Okay, 37. All right. Find the sum of this series. Let's look at 39. So now we're going to find the sum. $39. Find the sum. So they tell sigma 2i, I equals 1, 6. Okay, so let's find the sum. So the best way to do this, I have this written out here. Boom. Can you guys see that? So I start with my first term, I end with my sixth term, and I have to multiply it by 2. Okay? Now, the best way to do this is to make a table so we understand what's going on. And I'm going to make a table here. I have these fresh new pens. Fresh. Look at these. Oh, my gosh. Warm them up. Okay, here we go. So let's make a table. Hopefully they... Okay. We'll start here. We'll say N, and then we'll say, oh, it's I. So write this as I instead of N. 2 times I. First term, second term, third term, fourth term, and then the 5th term. Okay. What's my first term? My first term is, if it's 2I, my first term is 2 times 1, which is 2. What's my second term? My second term is 2 times 2, which is 4. My third term is 2 times 3, which is 6. My fourth term is 2 times 4, which is 8. And then 10. Boom. Well, I got my terms, my numbers. The sigma tells me to add them up.
Wait, Sensei, isn't there 6 terms?
Oh, there's 6. Yeah, let's put the 6th one there. Big time. Big mistake. Thank you. 12. So I got 2 plus 4. I think it's Ian that said that. Thank you. Was that Ian who said that? Thank you, Ian.
Yeah.
Thank you. 2 plus 4 plus 6 plus 8 plus 10 plus 12. And that'll be my answer. Let's see, what is this? 20, 30, 40, 42. I think it's 42. There's your answer, 42, I believe. Correct me if I'm wrong. But anyway, that's what it is, right? So you have this thing, you should be able to like, this tells me what to add. This tells me to do that. And so it's easier for the person to write it out, but it's hard for the person to solve it. Okay. That was 39.
Mr. Sanchez.
I'm going to do 47 and 49. Yes, what's up?
For the rule, isn't it 2 times I? So wouldn't it be 2 times 1 all the way across?
No. I is no, because I changes. I goes up to 1 all the way up to 6. So it's 1 all the way up to 6. I have 1, 2, 3, 4, 5, 6.
Okay.
Yeah, it's kind of weird. It's a weird thing we've never seen before. So it's like, but yeah, we'll keep doing these. Now, I'm gonna erase this in 10 seconds. 5, 4, 3, 2, 1. Okay, I'm gonna write 2 of these out. So here we go. I'm going to my board here. What time do we have 15 minutes? Okay. Okay, I'm gonna do 47 and 49. Do 47. Write them both up here. 47 is sigma. First term is 1, 35, and 1. And then 49, I'm just writing them out so you guys can see. 49, sigma. First term is 10. This one's kind of weird. Hopefully I can explain so it makes sense. And then we have I. Okay. All right. Let's look at 47 first. Okay. If you look at 47, I'll wait till you guys have it written down. I'll wait till you write it down. But 47 should be very familiar. Familiar, familiar, familiar. 47, if it looks familiar, it is easy. If it doesn't look familiar, it is impossible. Does anyone know what the answer for 47 is? You don't know what the number for 47 is. This rule right here.
I can't
Notice,
see.
what do you mean you can't see?
Like the very top of it, a tiny bit cut off.
Oh, okay. How's that?
Yeah, that's good.
Okay, this right here. See that rule? If this is 1 and we started at 1, my answer is going to be whatever number is in the top here. So what's my answer going to be? What's 47? Let's go with Angel Rojas.
35.
There you go. That's it. Boom. I'm moving on. Okay, I can't even tell now that I moved that up. Hopefully I should move this down a bit. You guys see the Brett? Can you see this now? I moved it down. You can still see that?
I could see it before, but yeah.
Okay. Well, I just want to make sure you can see this because I gotta write a lot down here too. Okay, notice this is I. So we're gonna use this rule here. However, we start at 10. And this says we need to start at 1. Okay. So what we need to do here, we can figure out. Angel, you're unmuted. I don't know if you mean to be Angel Rojas. Okay, you're good. So we want to go here. We want to say this says from the 10th term to the 25th term. But we know how to do it from the first term to the 25th term. So let's go figure out what is the first term to the 25th term. Okay? The first term to the 25th term, I'm going to go, so let's figure out this. The first term to the 25th term. Okay? So that's going to be n times n plus 1 divided by 2. 25 times 25 plus 1 divided by 2. Can you see that down there? Can you guys see that down there? Elise, can you see this down here?
Yeah.
Okay, cool. But I don't want 1 to 25. I want to go 10 to 25. So I'm going to subtract. I'm going to subtract 1 to 9 from it. The first term to the 9th term to figure it out, which is going to be the first term to the 9th term, I, which is going to be minus 9 times 9 plus 1 all over 2. That'll give me my answers. So let's calculate it out, and that should be it. Are there any questions on that thinking there? It's kind of hard thinking. I don't know. I want to know 10th term. So 10 plus 11 plus 12 plus 13 plus 14. Basically what I'm doing here is I want to go, hey, what's 10 plus 11 plus 12 plus 13 plus 14? It's 15 all the way to 25. But I can do 1 plus 2 plus 3 plus 4 plus 5 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 all the way up to 25. So I figure out this, but I take away this, and then I can get that. Anyway, 26 plus 25 divided by 2, 26 times 25 divided by, I needed my calculator for that. 26, so 325. So this here is going to be 325 minus this here, which is 9 times 5, which is 45. See you, girls? So 325 minus 45 is 280. So it's going to be 280. Of course, if you want, you can go 10 plus 11 plus 12 plus 13 plus 14 plus, you can do that too. And I want to try to get one more problem in. Are there any questions on this? Okay. Let's see. I'm going to do 55 because it's such a weird problem. Then I'll let you guys go. Okay, I'm going to erase this. Then we're going to look at 55. Again, look at your solutions if you need help. The solutions but don't use them to cheat, but use them to help you to understand it. You know what I mean? All right, so let's look at 55. Try to get out of here in less than 5 minutes. Okay? Okay, 55. For display at a sports store, you are stacking soccer balls in a pyramid whose base is an equilateral triangle. Now, I'm not quite sure I understand this, but okay, fine. With 5 layers. Write a rule for the number of soccer balls in each layer, then graph the sequence. Okay, so let's write a rule for each layer because you got to add them all up. So here's the rule. I'll just give you the rule and then we'll be able to get it all. It's 5 layers. Here is the rule. Hang on. I'm getting you the rule just a second. Oh my gosh, there's Harry. He's so handsome. Here's the rule right here. 1/2 times n plus 1. That'll give us each layers, right? There's the rule. To find the sum, we're going to go the first row, add it up to the 5th row, and we're going to write 1/2 times n plus 1. So go ahead and write that down. Class has got to be over soon, so I'm going to show you what the equation is, the graph. You can look at the graph. I'm going to get rid of this in 10 seconds, unless anyone needs it. Sure, 5, 4, 3, 2, 1. Okay, dink, dink, dink. And again, the solutions are here. Here's what the graph would look like. But check it out on your solutions. This is what the graph would look like. The first row, I have 1 ball. The second row, I have 3 balls. The third row, I have 6 balls. Anyway, they have the stack in the picture. And that's it. Okay, you guys did awesome. Are there any questions before I dismiss you all? You guys did great. Tomorrow's late start, and then Monday we have that weird schedule. We start like noon or something like that. Are there any questions? Okay, if you came late, let me know because have you marked absent. I will see you guys tomorrow. See you guys tomorrow. Bye, Miley. Bye, Bryson. Bye, Angel. Bye, Kevin. Bye, Linda. Bye, Thomas. Bye, Carlos. Bye, Alonzo. Bye, Dennis. Bye, Billy. Bye, Angel. Bye, Montserrat. All right. All right. All right. Sam, I don't know. Are you faking it? Are you really there or you just have your camera left on? Sam Adams. What's up, Samantha?
I was late.